All right, so hi. For those of you who don't know me, I'm Peter, and I'm going to talk to you all about AWS post-compromise persistence. So the way this is going to go is mostly I'm going to tell bad jokes here and there. Hopefully you will laugh. If you don't, force laugh. Just like that. So first, just to give me an idea, how many of y'all have used AWS? Just raise your hand. Right, awesome. So I won't go too deep into the details, and instead, I can tell you more about myself, because I enjoy talking about me. So currently, I'm a senior security manager at Capgemini. Most people haven't heard of Capgemini. I know I hadn't heard of them before they acquired the company I used to be part of, but they are a major IT consulting firm based out of France. In my free time, when I'm not doing, cybersecurity or lurking around in the cloud, I enjoy cocktails, and I really like funky wines. Like one wine I particularly like is called Munjabel, and it's hard to tell if it's either bad because it tastes like Band-Aids and vinegar, or is it supposed to taste like Band-Aids and vinegar? Thank you. That was one of the jokes. Excuse me?
Top shelf at 7-Eleven.
It might even be bottom shelf at 7-Eleven. All right. I also help run B-Sides Houston that took place this past September on the last day of DerbyCon, as y'all know, or may not know, but I hope to see you all there next year. You won't have to listen to me speak there. I only work in the background. I am a native Texan. People do like hearing that for some reason. I have no idea why. But you will catch me in cowboy boots and hats and belt buckles time to time. I've been known to speak at conferences time to time. I took a couple years off, but I'm getting back into the swing of things, so I apologize in advance if I'm a little rusty. And I really like the cloud, not just because of the things they pitch to developers, because of things are scalable and auto-scalable and infrastructure as code. It's because I believe it introduces a very interesting attack vector that most people don't think about. Everyone thinks about securing their apps, but not too many people think about securing the platform in which they host their apps. And if you would like to follow me on Twitter, that's me down there. I don't post very often, but when I do, I get into arguments with people all the time. So this is just going to be a brief rundown of what we're going to go over. I won't dive too deep into giving an introduction to AWS, since a lot of you raised your hands that you're familiar with it already. But we're going to cover some initial entry vectors for how people get into your platform, how people hide, or rather how attackers hide, persistence techniques, and then just a couple tips to help you harden your AWS installations. Sound good? You're going to have to work with me here. Sound good? Yeah. Thank you. I feed off your energy. If you have none, I have none. And it's just sad for everybody. So, why AWS? Honestly, everyone is moving to the cloud. Whether it's some sort of on-prem solution or hybrid solution, or completely based inside AWS, Azure, Google Cloud, DigitalOcean, what have you. And some big customers that I've worked with, ranges from Adobe, Netflix uses things for scaling, Yelp is hosted completely within AWS. I was surprised to find Kellogg in there because I didn't think they did too much besides make cereal. And of course, Amazon eats their own dog food. And more than likely, your own company is hosting things in AWS or planning on moving into some sort of cloud solution. One thing I find very interesting about AWS, and I meant to add a screenshot of this, is the memo that Jeff Bezos sent out saying that teams would no longer be able to, let's say, interact with people's backend. So I can no longer connect to your SQLite database. I can no longer connect directly to your MySQL database. Everything must be API driven. Everything must have a public-facing API. So that's one reason why I believe, at least for a period of time, they're in the lead of, let's say, the cloud migration march, or anything you want to call it that sort, because everything had a public-facing API. And that being said, due to the size of AWS, they have a large number of services that they add every single day, that seems like, and they have names that make absolutely no sense. I honestly can't tell what they do most of the time, and other people can't, which adds several interesting threat vectors. And in the times I've interacted with AWS's security team, they don't have bugs. Like, the various bugs you'll find inside IAM, they're like, no, they're totally intended. It's intended for this user to be able to do this. Yes, this user with no privileges should be able to delete EC2 instances. Yes, yes, yes. And then most importantly, they used to have a saying, no one got fired for going IBM, but these days it seems like no one gets fired for going AWS. And just to give you another idea about the scope of how big AWS is these days, this is just a couple examples of very large companies who are completely or in the progress of going full AWS, from using their data replication to using Glacier to using EC2 to using Lambda, what have you, to scale things. So while you can secure your apps, one of the most often ways people get into infrastructure is through people. And you can get in very simple ways. One of the most basic ways is just an infected device, whether it's your laptop, whether it's your phone. And I often find in my experience that it starts with browser add-ons. I know everyone uses them. Everyone has uBlock Origin running, or perhaps some of the other security related ones. But some of the lesser known ones are often bought and sold on the third-party market. So let's take myself, for example. If I have a add-on that has maybe 30,000 users, 40,000 users, and it doesn't do anything malicious, maybe it just hides certain iframes to act similar to that of uBlock. A lot of attackers are very active in these markets, in which they'll go out and buy these seemingly benign add-ons, and then just add malicious updates here and there to try to hijack the machine, to steal those cookies, to get the authentication tokens and the post requests, etc. Another great thing is phishing. As much as we try to train users to not fall for phishing, they still do. Is it an issue at y'all's companies? Yes, no? Thank you. One of the popular tools I like to use is Kingfisher. Kingfisher has an ability to deploy in AWS, usually within an S3 bucket, so it has a proper HTTPS certificate and everything, so it seems more legit to users. But admins for AWS groups are often targeted specifically by these people, by attackers rather. And a lot of this stuff comes from OSINT that they'll find, going on LinkedIn, to where I see that you're lead cloud architect for such and such company. Excellent. So now I know you're the person who I should be focusing on, who I should craft emails on, who I should pretend to be the package that you missed from UPS. And you just have to click here and, oh, by the way, could you log into AWS for this non-related reason? Source code repositories are also a large problem. I'm sure everyone's been in an instance to where they committed something that they didn't mean to commit. And often in a variety of these things, you can find stuff relating to authentication tokens, to usernames and passwords, to secure secrets, basically anything that you need to get your foothold into this AWS account. And a couple of very popular tools such as GitRob, Trufflehog, or GitHub has a live streaming API to where you can see every commit as it comes in real time into public space, and you can just set up some regex to look for various keys. And one of my most favorite ways and lazy ways is just social engineering. I can domain squat, get something close to your company. Instead of company spelled with an A, it's company spelled with a U. And I submit a customer support request to Amazon on your behalf. And I say, I'm locked out of my account. Can you help me? More than often, they will say, yes, we can. And they'll go ahead and unlock that account and give me access. You'll be surprised how often this happens. As secure as you want to be and as many doors as you lock, you always have to remember the cloud persists in someone else's house. And they can always open up a window for me to come through. And then on the low end of the totem pole, I'll just steal your laptop. I'll wait for you to be at Starbucks. You'll go to refill your coffee, get some sugar, and I'll just take it off the table, go about my business. Hopefully you're already logged in when this goes through. And then more on the service and infrastructure side. Does anyone remember when Datadog was compromised in 2012, 2013, a while back? they lost a number of authentication tokens, security secrets, et cetera, that tied into people's various AWS accounts or cloud accounts. With Datadog, you could do this monitoring, and most of the tokens were read-only, but not everyone practices very good hygiene with only giving out read-only IAM roles or tokens or what have you, which can lead to, once again, as secure as your house is, a chain is only as strong as the weakest link. Third-party repositories have become more and more of an issue. With the rise of front ends such as Node.js and some of the others that depend on third-party repositories that are hosted by NPM, where it happens frequently that an attacker either takes over a project that's no longer maintained or typo squats a project that's very popular to hope that people may mistype it and download their malicious binary instead of the one that you're intending. A second big one has been Docker. Most people do not cache the Docker images from Docker Hub locally, and instead they pull it down every time they do a build. So this runs into the same thing to where someone can typo squat, take over a popular Docker image, or create a popular Docker image, pretend that it's good for a long period of time before they decide to pivot into a more malicious fashion. Inside AWS, there's a metadata service that's only available to your EC2 instances or various other services within AWS. Inside this metadata service, there is a fair amount of, let's say, credential leakage because the services need this to talk to each other. So let's say I'm a database, for example, and you're an EC2 instance. The EC2 instance will communicate, hey, I am this user, these are my credentials, please let me store data in you, and I'll be like, thumbs up. But as a malicious actor, I can see these things going back and forth, I can log it, I can grab that username and password and use that and then to either pivot to another account, raise my escalate my privileges to more of an admin of the account or what have you. Another popular technique is AMI poisoning. AMI poisoning is when, similar to the Docker instance I had earlier, to where I create an AMI. Let's say, for example, there's no WordPress AMI that's pre-rolled in the Amazon store. I'll go ahead and create my own. You install it, you see it's all well and dandy, you're like, yes, WordPress is running, but my next update is gonna be malicious. And it's gonna grab keys, or it's going to send off credentials, whatever malicious acts I want it to do. I won't dive too deep into IAM because that can be its own talk itself. But we can all agree that it's very hard to configure, to say the least. As I mentioned a little bit earlier, most of the bugs are features and the features are bugs. But one particular instance I'll call out is instance profile abuse, which, let's say, for example, I compromised one of your developers' machines, whether I have a malicious browser add-on that grabbed his credentials, or I just plain stole his laptop. But I have a foothold in your organization, that's what matters. But he himself cannot access, let's say, the key vault, or he cannot access certain encrypted blobs or S3 buckets. Let's say you have an S3 bucket called secrets. He cannot access it. But what he can do is spin up EC2 instances. And if the IAM that we talked about earlier was not configured properly, it's going to be configured with the default role, which often has access to everything. So from that developer who has no access, I can then create an EC2 instance who can then access that S3 bucket on my behalf. Public EBS snapshots. I honestly do not understand why snapshots of virtual machines ever need to be public or usable outside your organization. I can think of a handful to perhaps you want to share a dump with a third-party user who's not part of your organization, but for a long period of time, the default state for EBS snapshots was public. They've now since changed it to private, and you must go through a series of hoops to make them public, but it's still a thing. If you go out there and just scan various EBS snapshots, you'll find a variety of data, anything ranging from social security numbers to IP to credentials, SSH tokens, etc. The same can be said about S3 buckets. As you know, S3 is generally the default blob storage for Amazon AWS that everyone utilizes. And due to IAM roles being misconfigured or S3 permissions being misconfigured, you often have public buckets that contain sensitive information that one can use to pivot or to escalate their privileges, or to persist inside. And a new one that I've really enjoyed using throughout some pen tests is VPC mirroring abuse. So in AWS, there's often an issue with monitoring the network traffic within your EC2 instances. You know, in the classical days, when you had your own data center, you would simply set up port mirroring on your switch. You would mirror that traffic off to a networking device such as Snort, Suricata, Bro, you know, take your pick. But I can't mail Amazon a switch and ask them, hey, can you span on this switch? They'll look at you like you're an idiot. Or they'll just throw away your switch. But luckily for us, they rolled out this service, I think some months ago, maybe 6 months, perhaps a year, to where inside your VPC, you can now configure your own virtual switch to port mirror to a device of your choice. Which as an attacker who only has, let's say, limited privileges, or I'm still trying to learn about your network, this is a godsend. I can simply mirror all your network traffic to a device that I control that doesn't have to be what's in your EC2 instance, and just analyze all your traffic, see all those metadata services of the various AWS services talking back to each other to try to glean more information, to get more credentials, just to really understand what's going on. So far we've gone through the ways that we can compromise the user and the way that we can abuse AWS services to get a foothold into the organization. The next is how we hide. So I'm now an attacker, and I don't want you to know that I'm in your organization. One of the first things you can do that most people do is I just stop logging. I turn off CloudTrail. You can't see what I'm doing if I turn off CloudTrail. As an attacker, I honestly want to avoid this if you're a mature organization because, one, you'll notice if your CloudTrail logs suddenly stop, or if your dashboards that you've built in Splunk or in your Elk stack have stopped populating. Another thing you can do is just straight delete them. CloudTrail is often stored either internally in some of the AWS services, or people will export it to a S3 bucket, or they'll export it somewhere else, and I just delete them. But one of the most sneaky things people can do is turn it off region to region. So if you're a distributed Amazon customer, so you host things in US West, you hold things in US East, et cetera, throughout the world, and I only want to practice in US West, I will only turn off logging for US West. So if your dashboards keep populating and you're getting alerts from the rest of the world, most people won't think that anything is going on unless they have a very granular view of what they do inside their console. Another sneaky way is adjusting the CloudTrail storage configuration. So when you do configure things to store to an S3 bucket, you can configure sizes like I never want this to go over a gig, or I want this to rotate every day and blow away the past 30 days of logs, et cetera, et cetera, et cetera. What you want to do is change the retention to 1 minute. So the logs are there, they're still logging, there's no alerts on that part, but they're gone. So you can't do any post-compromise analysis to see how I got in or what I did. Another thing is change the location of where they log. So if it's writing to your S3 bucket, perhaps I should write it to an S3 bucket that I control. So one, I can keep my legacy data to know what I've done in your network and know how I've compromised, know how I've kept persistence at the same time without setting off some of the usual alarm bells. Inside AWS, there's an option to encrypt your CloudTrail logs through AWS Key Management Service. From here, you can either specify a key, give them a key, ask them to generate a key, download the key, et cetera, to encrypt your CloudTrail logs with. In this case, I can substitute my own key inside there and just lock you out completely while the logs keep writing. I can delete the key that you have in there, or a little more sneakily, you can disable the key. So the key is still stored in the key management service, your key, not mine, but it's simply disabled. So CloudTrail can no longer access it to write logs, so it's no longer writing logs. A lot of people don't have that sort of error detection built in because technically all the services are still running as expected. And as we mentioned in the previous slide, VPC traffic mirroring comes back up. I can mirror that traffic that you're sending to your Suricata box or your Snort box, your IDS, simply somewhere else. I can disable it. I can mirror all your traffic to your security device and just overwhelm you with alerts and try to move around inside the chaos. And one of my favorite tools to use inside AWS is Lambda. Because Lambda, how many are familiar with Lambda? Right, so Lambda is the, say, serverless part of AWS. By that, I mean it's an event-driven serverless architecture. So for example, you can write a Lambda that, every millisecond it checks to see if there's anything inside of this S3 bucket, such as CloudTrail logs, and delete them as soon as they come in. So jumping back ahead, instead of deleting them at the CloudTrail level, like using the delete button, I use a Lambda call that goes in to delete them. You can also use Lambda to do any of the above things that I was talking about. So if you realize that I have been mirroring your traffic to your IDS device and overwhelming you, and you're like, all right, I need to stop that, it promptly goes back and turns it back on. If you start your logging again in CloudTrail, it will turn it back off. And if you try to delete my Lambda, you can have nested Lambdas that check simply to see if the Lambda before them still exists to re-enable or recreate that Lambda to go back out there. This can honestly be a bit of a pain to get rid of if you have enough nested Lambdas that sometimes you have to engage AWS support and just ask them to purge everything in the account so you can start from new. Which finally brings us to persistence. There's many ways to persist inside AWS, especially with the services that they run out every single week. I won't say this is an exhaustive list, but it's definitely some of the stuff that I've observed throughout different pen tests or post-compromise analysis. One of the most basic things you can do is simply create a new user. Creating a new user is noisy. Someone could be a small organization where you only have 2 cloud admins, so you're like, well, I see Joe and Bob. Why is there now Jill? Where did she come from? Did we hire a Jill? And why does she have access to our account? A more common way to keep in line with these things is create another user via typo squatting. Bill with 3 L's, Bill with 2 B's, Bob with 2 O's. 3 O's. Just something that won't stand out as much inside the logs. You can also create a temporary user. As of last time I did this testing, it may no longer be true. If you create a temporary user, and immediately delete them, their access keys are usually still good for about 30, maybe 20 minutes before whatever job runs in the background to purge their access runs. So this can be a very efficient way, utilizing Lambda to create and destroy new users and send yourself those tokens to make sure you can persist within that network. By default, users can have multiple access keys. I think right now the limit is 2. It might be a little higher now. But you yourself are only going to create 1 access key for yourself more than likely. So to not arise too much suspicion, I can just assign another key to your user that you use to have the same permissions that you do. People don't usually look at this as too weird because perhaps they forgot their other access key or they lost a file, they lost access to their LastPass. So this doesn't immediately stand out to say like, we've been compromised, we need to alert upon this. You can also backdoor existing roles. At this point, we're assuming that we have admin within the AWS console. So we can take roles that currently exist, let's say, such as Bob, who we were picking on earlier, and we can make sure we always have access to Bob's account, either via giving him more access to things that he shouldn't have, or making sure our access keys are always assigned to him. Backdooring AMIs that are used is often also very common. Similar to the AMI poisoning that we did earlier, it's where we take a well-known AMI and turn it malicious. In this case, we would take an AMI that they already use on a regular basis. So this is one of, I would say, the weaknesses of using infrastructure as code or using Terraform, such things to tear down the infrastructure and build them up based on templates. Your templates are only as good as the images you pull from, and if I backdoor that particular image that you're using to, like, let's say, add a user or add my SSH key so I can always access it, that's not great for yourself. And we can also, as mentioned earlier, backdoor more third-party services. These third-party services, like I said, can be NPM. They could be on GitHub, like any sort of open source tool. It can be a tool that you find out that the company leverages on a regular basis that you can afford to purchase and change the way it normally functions within there. You can also modify default security groups. They've gotten better these days at locking down security groups by default, like only allowing SSH in the beginning, only allowing 80 and 443 for web servers. But you can still change the default if you have admin. So you can add port 999 that you would normally use to connect to your interpreter that you installed on your backdoor AMI. I continue to pick on VPC traffic mirroring abuse because it's honestly a very powerful tool, and I really want to hammer this home for y'all. With the AWS services talking back and forth to each other constantly, there's so much information to be gleaned from here. So even, let's say you lock me out, if I've already started sending that port mirroring traffic to a device I control, I can just simply wait for the service to re-authenticate, grab those credentials, go back in, continue abusing your resources as we discussed earlier. And then there's still my best friend, Lambda. Lambda, 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 Lambda. You can use Lambda to just be a pest, honestly. And most people I recommend to disable services that they're not using within AWS, but disabling Lambda is honestly very difficult. You can use these Lambda calls, as I mentioned in the previous slide, to recreate your temporary user, let's say every 5 seconds. If someone deletes my bill with 3 letters that I created earlier, you immediately recreate them. If someone changes the backdoor AMI to a different one, you switch it right back. And since Lambda is event-driven, these things happen as soon as the change is made. So most humans won't have time to react, unless you're just consuming CloudTrail yourself and you see the matrix at night. So there's a couple ways that you can be a little bit more secure. Learn how IAM works, break down roles that have the least privilege. So if Bob only needs to spin up EC2 time to time, only give him that amount of privileges. Don't use your root account. When you first make your AWS account, you get a root account that has access to everything, and it's the equivalent of root on a Linux box. That should be used only for troubleshooting, working with support, but besides that, you want to use IAM roles. Guard duty is pretty nice. It ingests a lot of AWS logs by default. It looks for anomalies. It looks for things that more or less stand out. You can also configure your own custom rules in there to see why do we have more than 10 EC2 instances set up? Someone changed my AMI and we have more Lambda calls than we normally do. Git secrets is a tool from AWS Labs that scans each one of your Git commits for things such as SSH keys, secrets, etc. Anything that I would need to have access to your AWS console. I would also recommend Session Manager. Session Manager is a pretty new tool. I wouldn't say that you should roll it out in production yet, but you install a small agent or add an agent to your AMI builds, and that agent can log everything that happens on the device. So if it's Windows, anything that happens in PowerShell, anything that happens in Batch, and on the Linux side, anything that happens in Bash, any Python that runs, you have more or less a direct stream to see what a potential attacker was doing on this device. And like most things, logs are only really good if you could read them. Just like backups, I would recommend having logs in multiple places, whether it's locally inside AWS, in another cloud type service, and then perhaps on-prem. So if I compromise your AWS account and maybe compromise that third party, you still have a third copy where you have a chance to figure out how I got in to reverse things. And then turn on all the auditing. Logging gets expensive when it comes to storage, but you can't get around it. It's just a cost that has to be eaten. You need to turn on CloudTrail, you need to watch all the configs, you need CloudWatch. So a question I commonly get is, where should I store my logs outside, Guard Duty or CloudWatch, what have you? S3 buckets are an option, and a lot of various companies such as Backblaze or DigitalOcean have replicated the way that the S3 API works. So if you're already pushing things to S3, you can easily tie into some of these other services to make sure things are backed up properly. No questions? All right, with that, thank you.